I love the MSX, and this Panasonic CF2700 is no exception. But I don't have an MSX compatible joystick. Some MSX games support 2 independent fire buttons. I could use the keyboard, but I don't want to play with these huge cursor keys, so I was looking around to see what I could use instead. Growing up in the 80s and 90s, I was and still am a big fan of the Sega MegaDrive, or the Genesis as it was known in the US. Its kidney bean shaped joypad feels very natural to me. Unfortunately, the joypad isn't compatible with the MSX. But we're going to fix that. And we're going to fix it right now.
Mark fixes stuff. This video is sponsored by PCBWay. You can get an instant quote on a variety of services, or browse a library of talented makers' designs, add them to your cart, and have them delivered directly to your door.
This CF2700 is a European model, and it boasts the Panasonic name. In Japan, the same machine was branded as national, with both of those brands being part of the Matsushita Denki Corporation. But for some reason, and it was probably a marketing decision somewhere, the European release had twice as much RAM as its Japanese counterpart, with 64 kilobytes included, instead of the Japanese model's 32 kilobytes. MSX computers weren't massively popular in the United Kingdom. In fact, the only model I even recall seeing was a Toshiba HX20. And back then, games released on cassette for the MSX were often lazy ports from the ZX Spectrum. Because of the architecture of the MSX, the programming, if not ported correctly, would often result in a game that ran slower than its Sinclair counterpart. This meant that the really good games were on cartridge, and often had to be imported from Japan, at a huge cost. This MSX is fairly standard stuff as MSXs go. It has 2 DE9 connectors for joysticks, cassette, printer, RF and composite video outputs, and a really nice keyboard. But not nice enough to play Galaga on, sorry. I really want to use the MegaDrive controller, but due to the amount of buttons and the logic inside the MegaDrive pad, it's simply incompatible with the MSX. In fact, plugging a MegaDrive controller directly into your MSX could potentially damage the computer due to the way it muxes the control signalling. That's where Tor Erik Bakalunda comes to the rescue with this cheap and easy to build project, the MSX Mega Adapter. It doesn't simply make the MegaDrive controller a compatible 2-button pad. It was built to be a version of the Joy Mega project, which was refined by Snatcher Alpha, but originated by Sergio Guerrero Morales. Let's get set up to make this simple project from start to finish, and then we can test it with some games. We will need Tor Erik's PCB from PCBWay. His link is below. A couple of 1N5711 diodes which will be used to avoid bus contention. A 100 nanofarad decoupling capacitor. A 74HCT04 hex inverter. And a socket for the chip. A 9-pin male socket to plug the MegaDrive pad into, and a female 9-pin socket to plug into the MSX itself, although I'll be using an extension cable for reasons I'll explain later. First things first, the board has been hanging around for a while, so I'm going to give it a clean with isopropyl alcohol as a precaution. This will break down any grease from my fingers, as well as giving us nice clean solder points. Do I always do this? No. but I'm videoing this so I'm on my best behaviour and showing you my best practice. When doing any project, it's important to think about your component order. Some components might make it difficult to install other components if you install them first. I usually use a height approach. Start with the parts with the lowest profile to the board. There are exceptions, but it's a good way to start thinking about it. On this board, I'm going to start with the 2 diodes followed by the decoupling cap. Because they're small and close to the PCB surface, they'd be more difficult to place should I solder in the socket first. Diodes have a polarity. That's to say they have a right and a wrong way to be inserted into the board. They have a positive leg, or an anode, and a negative leg, or a cathode. Diodes often feature a stripe or band near their cathode terminal, denoting their polarity with the same reflected on the PCB. Their job is to allow current to run in one direction but not the other. Current can flow from the anode end to the cathode, but not the other direction. There are some exceptions to this, and a high enough voltage can flow from a cathode to an anode if the voltage gets too high and exceeds its breakdown voltage. But that won't be a problem in this circuit. These diodes are actually connected to pins 6 and 9 to prevent those signals conflicting with each other and causing bus contention in some rare and specific cases in the MSX. With the diodes installed and the leads clipped, it's time to install the capacitor. And just a note for the eagle-eyed out there, the anode of the top diode hasn't got a great solder joint, but I came back and fixed that a bit later. Sometimes it's hard to see from behind the camera. This is a simple ceramic disc capacitor. When soldering, it's important that the leg or lead of the component and the pad on the board are heated evenly. I try to place the tip of the soldering iron so that it's touching the leg of the component and the solder pad at the same time. Then when the solder is applied, it will be drawn evenly towards the heated surfaces in a physical phenomenon called capillary action. Next, it's time to install the socket. To keep the socket in place, I'm going to use a bit of blue tack. I'm using a socket because if I don't, some of my viewers get really upset. I test my logic chips in my chip programmer before I install them, but I do understand the concerns. It's because if you source your logic chips from eBay or AliExpress, they can sometimes come through as second-hand system pulls or non-working parts. They can sometimes even be remarked chips that aren't what they say they are. I do try to be careful about where I buy my things from, but you can never be sure. Most EEPROM programmers have a logic test function, and that can be really handy for weeding out the fakes from the real deal, saving yourself some unsoldering. But today we'll use a socket. I'm not going to lie, it's incredibly fiddly filming around a camera. On a couple of these legs my soldering tip placement wasn't ideal, but it does give a good illustration of how it can go wrong. So here I didn't heat the pad enough, and you can see it ended up blobbing around the pin until it eventually pulled onto the pad secondarily. And that's the socket soldered. Where the blue tack's got a bit warm, it can sometimes leave a residue behind on the component, but that's easily cleaned up with a bit of a dab. This board will act as a translator between our Sega MegaDrive controller and our MSX computer. So we're going to need male and female DE9 connectors. Note that I said DE9 and not DB9. Warning, here comes a contentious issue. The DE9 D sub 9 pin connector is often mistakenly referred to as a DB9 connector. The D simply stands for the D shape of the connector, but the following letter is meant to represent the size of that connector. Because most early computers had one of the larger DB25 connectors for serial and parallel ports, people started calling the smaller 9-pin connector DB9. But in reality it's a DE9 with E being the smaller size, and likewise a standard VGA connector is a DE15. But I digress. And no, this is not a Commodore 64. Blasphemy. Let's stop talking about the size of our ports now and crack on. The important thing here is that we put the right gender ports in the right positions on the PCB. Our DE9 female connector will need to go on the MSX side. This will become our new joystick plug. I'm going to solder the data pins of the port into the board, but I won't be soldering the support pins on either side because I intend to remove them. And the reason why will become apparent later. Although, as you can probably already guess, they would get in the way of inserting the port into the MSX anyway. The DE9 male part needs to go on the side that will accept our MegaDrive connector plug. Again, the threaded screw mounts will need to come off later, but first we'll need to solder the pins into place. I'm a massive fan of this sort of project for retro hardware, so I take my hat off to people like Tor Erik Bakalunda and everybody else who releases projects for free on GitHub or PCBWay Plus. Check it out, there's loads of good stuff. With the ports installed, all the soldering on the Mega MSX adapter is now complete. There's just one final thing to do. And that is to install the logic chip. Pressing evenly and firmly, our hex inverter slips into the socket. And with that, our interface is complete. But I don't want to leave this project naked so that everybody can see my ports. And I certainly don't want it hanging out of the MSX like a little lever waiting for me to catch it. So, after taking a few measurements, I popped over into Tinkercad. Its toolset is rudimentary, but it did allow me to create a quick shell for the board. I still find it incredible that we live in a time where you can design something on your computer in a web browser, export it, and then put it on a 3D printer, making it a tangible item in your world. What a time to be alive. I made a lid with some lugs so that the two parts can just press fit together without needing any screws. We might need a little glue though. And this is the exciting bit, because it can be either magic or tragic when you get your 3D print next to your part. And no, it doesn't go in, but we were expecting that, and if you remember, we need to take these lugs off. And doing that gives me an opportunity to shamelessly plug the Kaiweets ES20 electric screwdriver set. This thing's so handy, and it comes with a little 5mm socket, which is great when you're taking these off or taking apart an Amiga. There's a link below, and if you buy one, I'll get a little affiliate kickback. By removing the mount screws, we also remove the outer shell of the sockets. So we'll use a little bit of glue to pop those back on. Although this side seems quite robust. This side will need glue, however. I like to use a rubber cement. It's a nice all-purpose solution, and it doesn't introduce crazing fumes like using super glue. This glue's super strong, but the outer casing will be held on by our 3D printed box anyway. And that's a good fit, well, at least horizontally. Popping the lid on, we can see there's a slight misalignment of the ports with the holes, but it's only aesthetic. But of course, I couldn't let it go. So I had another go at designing one. I've tightened up the tolerances on this one and resized the DE9 connector holes for the two different gender connector sizes. let's give it a whirl. Hooray, it looks excellent. But with my new tighter tolerances, I've just realised something. The case doesn't shut properly, and I know why that is. The board is being forced upwards by the support connectors, which we haven't yet removed. It's a delicate job taking these out, requiring brute force and ignorance. Once we've removed these, the board should sit a lot flatter. It makes about a 1.2mm difference, which is quite a lot with the tolerances I've been designing to. And that seems a lot better. And our push fit lid goes on nice and snugly without being forced up in the air. I'm really quite happy with this. What do you think? With our interface completed and not naked anymore, it's time to test. I'm going to use this joystick extension cable so that the interface isn't sticking out of the MSX game port. The connectors mate snugly, so I'm pretty happy with this. Now, not a huge amount of games use the second button on the MSX, but enough do to make not having one available feel annoying. This would make testing all the buttons impossible, but there is a program for the MSX which does just that. HidTest.com by FRS works for a whole host of HIDs or human interface devices. And it shows us that we have a working adapter. Obviously no classic software supports this amount of inputs, but some homebrew like the Sofa Run ROM launcher does. But I just want to use the familiar pad to play with, even single button games, so first up it's time for a bit of Gallagher. This is a one button game, and it's so much nicer to use the pad than the arrow keys. This game is a Namco classic, and I think it still holds up today. No, I take it back, it's a rubbish game and it cheats. Joking aside, this conversion is excellent. Moving now to a two button game, it's time for a little Salamander. And full disclosure here, I'm absolutely terrible at side-scrolling shoot-em-ups. I personally don't think that this conversion takes full advantage of the MSX hardware, but other people will disagree. It's a good test for our interface though. Salamander uses the primary fire button for, well, fire, and uses the second button for switching weapons. Again, the pad is excellent for manoeuvring, and I find it much better than a joystick even. The smaller movements required on a joypad make my terrible reactions much less of an impediment. Although remember, I do suck at side-scrolling shoot-em-ups. Told you. After stretching our Salamander's legs, I chose a third and final game, but this time I went for something from 2023. The Goblin is a great puzzle platformer. Originally created for the Spectrum by Hicks, this conversion to MSX by Hicks and Mananook is great fun. As I said earlier, in the 1980s there were a lot of Spectrum ports on the MSX, well, at least in the UK. They were often lazily programmed, but this was not lazily programmed. It's sharp, responsive, and a joy to play. Drinking beer and belching in order to lock up your demons. That used to be a good Saturday night for me. I've got a huge amount of love for the MSX software library. And then after that we've got MSX2 as well. With that in mind, I'll be doing some more MSX projects in the future. Thank you so much for watching. And thanks so much to the amazing patrons appearing on the screen right now. My patrons really keep me going. In fact, I couldn't produce this content without their valuable support. If you'd like to become a patron, come along to patreon.com/MarkFixesStuff. Patrons get exclusive access to ad-free versions of my videos. There's also exclusive patron vlogs. And for a limited time, patrons will gain the super ability to fire custard out of their fingertips. That might be a lie. Go and watch one of these other videos. I can't believe you're still here, to be honest. Go on, click one. See you later. Bye.